Hi to everyone. Welcome to our presentation today. We'll be presenting the Signatech Ultra Portable RF recording system. We'll start by giving a brief introduction to the architecture, capabilities, and benefits of the portable version of these systems, then discuss the solution components in more detail, and finish with a quick look at how to configure a system. We'll start by giving a high-level description of the overall system function and the components involved. On the left, we have the RF down converter, which frequency translates the incoming RF signal to a lower IF frequency. This signal then goes to the digitizer in the middle box, and finally, digital streamed via Thunderbolt 3 to the hard drive storage in the controller on right. And let's just take a quick look at that signal flow. Typically, your RF input is a very low level signal. It's in the millivolt or microvolt level, typically coming from an antenna. This then goes through the down converter and follow the green line, goes through over to the digitizer where it's converted from analog to digital. The digital stream then goes via Thunderbolt 3 over to the controller. The down converter can accept signals from 9 kilohertz to 27 gigahertz and has 3 bandwidth selections. The selected bandwidth determines whether it uses 1 or 2 digitizer channels. The RF input includes a bank of pre-selector bandpass filters along with amplifiers and attenuators to handle a wide range of signal levels. The down converter setup and control are done via gigabit Ethernet and from the controller application software. The digitizer in the middle is the heart of the system. After it converts the down converter output from analog to digital, it manages the process of real-time streaming. This is accomplished using Signatech developed technology and uses a large onboard FPGA working with extended high-speed memory in the digitizer. The digitizer also has capabilities for external triggering, external sample clock, and accepting or supplying a 10 megahertz reference clock. After conversion, digital data is streamed to the measurement controller where it is stored on the local hard drive system. The Windows-based application, Spectroscope Rt, recognizes the system components on startup. It then manages setup, control, display, and recording. All aspects of the system are done through this application interface. There's also a remote client network control option that supports multiple users. The Spectroscope Rt application allows for very powerful capabilities with a turnkey Windows-based user interface. For those developers that wish to create their own software control, display, and recording programs, there is a full programming support via SDK with libraries and drivers for the system components. Now let's talk about the system capability and benefits. It's reasonably lightweight for the real-time recording capability it offers. At 24 pounds, it can be transported as carry-on luggage on most airplanes. The Spectroscope Rt software allows users to start a recording and monitor the signals being recorded in both time and frequency domain. This can be especially important for situations with long recordings to make sure the signals are still present at the correct amplitude and frequency. Digitizer FIFO buffer overflow is also instantly flagged by a pop-up error window. After recording, signals can be viewed, analyzed, or selectively saved for further analysis. With 3 IF bandwidth settings, the system allows users to balance IF bandwidth with total recording time. There are 2 down converter IF bandwidth options one can select at time of purchase. We'll take a look at these later in the configuration. Users select 10, 40, or 80 megahertz bandwidth for longest recording times in the superhet mode, or 100 or 160 megahertz bandwidth for wide frequency coverage in baseband mode. And in the superhet mode, we use one digitizer channel. In the baseband mode, we use 2 digitizer channels. The application software manages all aspects of the user operation and includes setup, recording, analysis, and data export. The Spectroscope Rt application was developed with customer input over many years to include features and functions most important to typical RF signal recording and analysis applications. The modular architecture allows users to upgrade or expand any one of the 3 components as needed. For instance, the portable measurement controller can be replaced with a rack mount version if more RF channels or deeper recording time is needed in the future. This modularity is an important distinction compared to other non-modular box solutions. The ultra-portable system is sold as a complete turnkey system with all software loaded, fully tested, and ready to use. The analysis displays are available in all modes of system operation: record to memory, record to disk, and recording playback via SpectraView RT. Shown here, left to right, top to bottom. And I'm going to just highlight these as we go. And if you'll notice, what we have here, we're showing almost all of these except the last one down here. This is time domain. The rest are all frequency domain. And we're looking at 100 megahertz of bandwidth. So it's amplitude versus frequency. And the center frequency is 1,000 megahertz or 1 gigahertz. This one is histogram, composite power spectrum, persistence, high frequency spectrum, spectral map, time domain I and Q. The spectral map is very popular with customers as it shows frequency versus amplitude versus time. The top trace shows the signal level over time. It's a rolling display. Next, we'll discuss the flexibility with handling recorded data files. When recording such large files, users need flexible options to manage the naming and maximum size of the files. The Spectroscope Rt software allows for recording session to be limited by elapsed time, file size, or both. During recording, large files can automatically be split into multiple files of specified size that are named sequentially with user-selected file name parameters. There is a separate program used to view large recorded files for playback, SpectraView RT. In addition to all analysis features, it allows for screen compression of large data files to identify important signal features, which can then be selectively saved into smaller files. Provision is made with full header file documentation to allow for export of recorded files into other programs for further analysis. This would include MATLAB, LabVIEW, Excel, and existing user-created analysis programs in languages like Python or C. We previously mentioned the correlation between bandwidth and maximum recording time. Now let's take a look at this in more depth. And this is a sort of a busy table, but essentially what you're looking at here down this column is the receiver bandwidth from 10 to 160 megahertz. And then we see the number of channels used. In the first case, it's 3. Channel 1, channel 1, channel 1, channel 1, and 2. So 1 channel and then 2 channels. And then we see the complete the time it takes to the recording data transfer rate in megabytes. Here's a few examples. With 4 terabytes of recording capacity, we can record for 5.5 hours at 10 megahertz bandwidth. If we increase that bandwidth to 80 megahertz, the time is reduced to 2 hours and 13 minutes. With the full 160 megahertz of bandwidth, it's halved to 1 hour and 6 minutes. This corresponds directly to the digitizer sampling rate required to support the bandwidth being acquired and the number of input channels being used. The limits on these recording times are imposed by the amount of storage available in a small portable measurement controller. When using a larger desktop or rack mount based systems, the recording time can be substantially longer. Now let's take a look in detail at 3 system components. This graphic shows Thunderbolt 3 enclosure with a 16-bit digitizer card inside. The unit is AC powered and measures about 10 inches tall by 5 inches wide and weighs 12 pounds. The digitizer has 2 input channels, trigger in and out, and clock in and out ports. These connections allow for flexible integration into systems with external requirements for pulse triggering, 10 megahertz reference, or external sampling. The internal digitizer includes 8 gigabytes of FIFO memory for real-time buffering, which allows for gap-free data transfers to the controller storage. Because this is a modular system, the digitizer can be relocated to a desktop or rack mount enclosure with a suitable PCI Express slot if requirements change over time. The RF down converter module is a small package that measures 6 inches wide by 2.5 inches tall and weighs 6 pounds. Now we call this a down converter, but it also may be known by other names depending on the industry. Some might refer to it as a tuner or a receiver, or in reality what it is, it's a spectrum analyzer without a front panel and user interface. It's available with different input frequency and bandwidth options to accommodate different system needs and budgets. All models utilize RF preselector filter banks to minimize out-of-band signal interference. The 27 gigahertz model has 21 of these filters in the RF front end. It can accommodate a wide range of input signals with a maximum safe input level of plus 10 dBm. The front panel has RF input and status LEDs. The rear panel has IF outputs and external 10 megahertz reference clock in and out ports. The unit is powered by a 12-volt DC and is supplied with a small AC power supply. For more detailed technical specification on the down converter or 16-bit digitizer, please refer to the ultra portable datasheet available on the Signatech website. The measurement controller is window-based and has options for up to 128 gigabyte of processor memory with 4 terabytes of solid-state storage memory. The display is 15.6 inches and weight is 5.7 pounds. It's battery powered and furnished with an external AC adapter. In addition to the 2 Thunderbolt 3 I/O ports, it also has 3 USB 3.1 ports, which can be used for high-speed data backup to external storage. Now let's take a look at how to configure a system. The entire configuration is done via the first line. I'll highlight this. So this is the one line that does the entire configuration, and each of these blocks highlighted in black, pound 1, pound 2, pound 3, correspond to the selections you make. To make ordering easy, we've consolidated these into one line. The first step in configuring the system starts with the RF down converter by choosing the maximum input frequency and bandwidth. So the options available here would be 8 gigahertz, 18 gigahertz, or 27 gigahertz. And then your bandwidth options are 10, 40, and 100 megahertz, or 10, 80, and 160 megahertz. Next step, you want to look at the configuring the controller. The selections here are system memory, 16 through 128 gigabytes, and then your main controller system recording drive memory, up to 4 terabytes. most customers would probably select the 4 terabytes. Finally, you select the 16-bit digitizer model to be used. There's 2 available, and the selection is dependent on the maximum bandwidth chosen for the RF down converter. The 100 megahertz bandwidth option requires 200 meg sample per second digitizer, and the 160 megahertz bandwidth option requires the 500 megasample per second digitizer. The configuration process should be easy, but typically there will be application and budget questions. Please contact our application team or your local country representative for help and guidance to finalize the configuration. We will guide you through the process, answer technical configuration questions, and then send you a detailed configuration and price quotation. For more detailed information and specifications on this system, please visit the Signatech website located at www.signatech.com. That's shown on the line here. All right. We invite you to contact us directly to discuss the needs for your application. There are multiple ways to do this depending on your preference. You can call us, send us an email, or visit the website and use the form located under Contact Us on the top right of the homepage. We look forward to hearing from you. That ends the presentation. Are there any questions?
Great. Well, thank you, Bob. And thank you, everyone, for logging in. Again, I'll send a copy of the presentation as well as a link to the recording and via email and probably tomorrow morning. If you have any other questions, feel free to reach out to us. And thanks again for attending.